effort to learn.
Exactly. You got to put in effort to learn. There's passive learning and active learning. And it's basically saying that, at the end of our learning process, you could be very much, you get a lot of information coming into you, but at the end of all your learning, you could pretty much be the same person you were at the beginning if you don't actively come to it halfway. I want to share something with you. I think Mormons are notoriously hard on themselves. I think that's one of Satan's tools. I think that we kind of beat ourselves up every time we hear a good talk in conference or something like that. We often focus on what we're not accomplishing. We're very good at coming to the information halfway in this class. And a big part of that is your homework and the time you spend coming to the information on your own. You think about sports. In sports, we teach a concept and then we run through drills. We let the children or people who are participating in sports do the actual physical activity. We don't just tell you and then say, "Oh, go play your game." We tell you, and then we run through drills to practice it, right? And so we're very good at doing this quote. But I want you to understand today, we're going to do some passive stuff in this class where I'm going to outline a bunch of stuff that's on the test, and then you're going to actively do a few things here in class to accomplish it. But then the real action of coming halfway is at home. The test is open for Chapter 2. I'm going to start off the class today by telling you this is a hard test. This is a challenging test. Not too hard and not too challenging. But please do not, in your preparation, please do not approach this test as if it will be like Chapter R or Chapter 1. It will be a much more challenging test than Chapter R and Chapter 1. And you need to be ready to take it. And you know that before you take any test, even though it's open in Canvas, you need to have your visual chart and your practice test review in blue completed, right? So today we're going to do something a little bit different. Brother O'Shaughnessy is joining us here today. We're going to be taking video of lecture in an attempt to create a higher quality video than just the one that Zoom provides for us after class for me to provide a link to. So you want to go back and look at lecture. We're going to see if this other video we take is a higher quality one. We'll probably have to post it on YouTube and then create a link for you to get onto my YouTube channel to look at that. Yeah, Bro.Rich has a YouTube channel. So lame. It's not surfing or skateboarding or anything cool. It's just me teaching math. I mean, it's like I have 2 followers. Nothing cool. I wish.
That's one more than me.
Ah, all right.
I only have my wife. That's it.
Yeah, that's right. So, okay. One of the cardinal sins in teaching is a concept called teaching students to the test. You know the adage that we should don't just feed a person for a day, but teach him, how to, basically it's the fishing analogy, give a man a fish or a woman a fish and you feed them for a day, teach them how to fish, you feed them for a lifetime, right? And so when we teach you to the test, that means that we teach you how to accomplish everything that we're going to test you on, but then if a different test is given, you can't handle it, right? And that's a problem. And so I'm going to kind of break one of the cardinal rules of teaching today, and I'm going to teach you specifically what's on this test, but I already told you I'm going to do this, and we're never going to have a review like this, and we've never had a review like this previously, and we'll never have a review like this again. But I think our Heavenly Father also, He doesn't just throw us in the deep end. And so this is going to be one of the most challenging tests you see. You've got word problems on it. So I'm going to kind of guide you, because the main thing I want you to understand is on this test, I don't want there to be any surprises. I don't want you to look at it and be like, whoa, I didn't know that was going to be on this, okay? I want you to be very comfortable. So today, what I'm doing is I'm breaking one cardinal rule to kind of compensate for the concept of anxiety. I really want to address your anxiety about this test. Make sure you're very comfortable to understand this is what's on this test, and then focus on knowing those principles. But throughout the semester, throughout the last couple of weeks, we haven't been teaching you just to the test. We've been teaching you concepts. We've been teaching you how to fish, ultimately, okay? Okay, draw your attention to the far left board. We're going to go back from the left to the center a few times. I'm going to be instructing Kenny and Stefan which board we're going to be going to. I'll say, board left, board center multiple times. So the first 8 problems on the test. So the chapter 2 exam, numbers 1 through 8. These are all section 2.1, 2.2, and 2.3, where we are dealing with the 3-step process to solving, okay? Let's think about the 3-step process to solving. We have the addition principle, agreed? Yes? So a problem like, we could say a problem like x plus 3 equals negative 12. Hard or easy? Easy, okay? We have the multiplication principle. Maybe something like 3/5 y equals negative 12, okay? In fact, you know what? I'm going to do negative 11, all right? Relatively easy. Throws a fraction in there, definitely adds something into the mix. When we put the two principles together, when we use those together, this was all 2.1. This was all 2.2. In the beginning of 2.3, we used them together, and we had 2x plus 3 equals negative 15, okay? And then we saw, in the rest of section 2.3, we saw everything in all of its glory, We saw parentheses. We saw, like terms, and we had to get all of our variables to one side. We definitely saw fractions. There was occasionally a problem that had decimals in it. Did we have to get rid of the decimals? Yes or no?
No.
No. Okay, thank you. Everton. Nice new mask, bro. Or maybe it's just one you haven't been wearing in a while. Okay?
That's neat.
That's cool, man. Psychedelic. Okay, so here's what's up. The first 8 problems of the test. Let's think about this. What's 8 times 3? Loud. 24. There's 25 problems on the test, so almost 1/3 of the entire test is the 3-step process to solving in all of its glory. And what I want you to understand is you're going to see the simplest of problems where we just use the addition principle. Problem like this. Where we just use the multiplication principle. Problem like this. Where we put the two together. Problem like this. These are simple. 2 bigger problems where we have parentheses, like terms. We got to get our variables to one side. We have fractions. We got to get rid of them. All that kind of stuff. Okay? In these 8 problems. One thing they really emphasize on these 8 problems is the one side concept. You're definitely going to have variables on both sides of the equal sign multiple times in numbers 1 through 8. Or you're going to have to get your variable all to one side. Now, if we had 2 or 3 hours together, I would put problems on the board, have you work them out right now. But our time today, you listening to this? Our time today, we're going to emphasize the stuff you struggle with the most. What do you struggle with the most? Word problems. And that's where we're going to put most of our time, and I'm going to give you time to do some. I'm going to do them with you. But I'm going to put a few things on the board, and you're going to have to meet the information halfway and go do this. Do you feel comfortable reviewing these on your own?
What?
Yes or no?
Yes.
I think so. I think you should, because we spent a lot of time on this, okay? Now, another concept that we deal with in problems numbers 1 through 8 is the concept of all real numbers versus no solutions. Did we discuss this in class? Yeah. And if you go back to your notes, it said that when solving and our variables cancel out, I'm left with either a true statement or a false statement. In a true statement, my answer is all real numbers. A false statement was no solutions. You're going to have a problem in 1 through 8 where you're going to have to figure out, is this all real numbers or no solutions? You cool? Okay. Okay, what I want to do is I'm going to go to the middle board. Let's go to the middle board. So one of your major assignments right now is to complete a visual chart. And I want to talk to you about visual charts a little bit differently than we have in the past. Nothing too dramatic. But I think that, we can get really rigid sometimes. Like, we had 6 boxes in our first visual chart because there were 6 sections in our chapter. Your visual chart really should be a representation of what is best for you to prepare for the test. It should be organic. It doesn't have to be 8 boxes for 8 sections. It doesn't, all the boxes don't have to be the same size. So if I was in your position, I just told you that 1/3 of the entire test is about the 3-step process to solving. So I would take about 1/3 of this space and I would dedicate it to sections 2.1, 2.2, and 2.3. And instead of having one box for each of these sections, I would combine it all together because this is all about the three-step process. And I would definitely have the three-step process. You know, we know the goal of solving, you know, we can talk about that. And then we have A, B, C, 2, 3. I'm not going to write this out. Fractions, parentheses, like terms. You've done it 6, 8 times now, right? You know what to do. We don't need to write this out. But you definitely need gobs of examples in here. And I would have at least about 5 examples. And I would draw on these concepts we're talking about. I'd have stuff with fractions. I'd have one with some decimals in it. And I'd write the problem and do the whole thing and have that all in here. We talked about the balance rule in our notes, okay? And we had a little scale. We said whatever we do to one side, we do to the other, and all that kind of stuff. I would incorporate all that into 2, 1, 2, 2, and 2, 3. And definitely you need to address all real numbers and no solutions. Okay? So a little different take on your visual chart there. You don't necessarily have to do it all separate in different boxes. Now, you don't have to do it my way either. This is just a suggestion. If you want specifically to have 2, 1, 2, 2, 2, 3, your mind compartmentalizes better, you like that, then do it. But I'm showing you a different way as well. And that everything doesn't have to be equal sized. You know, I would give a little greater size to things that are greater capacity on the test. Okay. Our next 2 sections, I'm going to show you something interesting here. We have 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6, 2, 7, and 2, 8. I'm going to just quickly outline for you what we covered in each of these sections. So in section 2.1, we definitely talked about the addition principle. 2.2, we did the multiplication principle. 2.3, we did the 3-step process to solving in all of its glory. Fractions, parentheses, like terms, getting all your x's to one side. 2.4, we learned how to solve formulas. 2.5, we learned the is of what percent problems. 2.6, we had word problems and our 6 types that we learned. A little bit of that was at the end of 2.5. 2.7, we learned how to solve inequalities. And in 2.8, we had inequality word problems. Okay, let's leave that for just a moment and come back to this board over here, okay? I want you right now, I want you to take this problem, 3/5 y equals negative 11, and I want you to solve it, okay? Go for it. I'll give you a minute, maybe 4 to 5 seconds. Get your top 5 candidates picked. Los Angeles.
Harder than I thought.
Okay, you done? Okay. So there's a couple of ways we can do this problem, but what I want you to understand on this one, okay, we were taught to get rid of fractions, agreed? So do I have fractions, yes or no? What's the LCD? It's the only D, right? It's the only denominator, it's 5. So we can multiply this side by 5 and this side by 5. Notice this is just the multiplication principle problem here, okay? And you have one like this on the test, okay? These 5's cancel out, you're left with 3y equals what? What does it equal?
Negative 55.
Negative 55, okay? Now what do we do? You tell me. Yep, divide by 3, divide by 3, okay? And y equals negative 55 over 3. Okay, 2 things I want you to see in this problem. They're going to give you some easy problems on this test, and they're going to give you a few that challenge you a little bit more. And the ones that challenge you will have fractions in them. I don't want you to be freaked out. The second thing I want you to understand is this. Is that answer true? Who got that answer? Raise your hand. Good. Okay? Did you divide it and create a decimal from it? Okay? There won't be a divided decimal answer on the test. They'll leave it in this format, okay? Here's the thing I want you to get. That's not a clean, pretty answer, is it? It's not an integer. It's not a whole number. And sometimes when you're taking a test, you can get yourself in a little bit of a panic mode when you get an answer like this, just like, oh, I'm stupid. I did something wrong, okay? And you gotta be able to shun those negative voices out of your mind, okay? Okay, you gotta shun those negative voices out of your mind. You say, be gone, math Satan, okay? And understand, we're gonna have some answers like this on the test occasionally. And so look at your multiple choice options, and you're like, whoa, I think I did this right, you know, and feel good about yourself, okay? Did you know that all of us talk to ourselves? Not necessarily out loud, but we all talk to ourselves in our mind. Did you all know this? We do. We have conversation with ourselves all the time. And I would venture to say that Satan knows that you talk to yourself, and him and his host are always trying to infiltrate that conversation. Always. There are studies done that show that a certain percent of what we tell ourselves is negative. Do you know what percent that is?
B.
What?
B.
You are dang close, Joel. It's 87%. 87% of what we tell ourselves is negative. To me, that tells me that Satan is infiltrating that conversation. Successful people turn that around and flip the script to about 20% of what they tell themselves is negative, and they use that as motivation to get better at stuff. Okay? When you're taking a test, I don't want you sitting there saying, I'm stupid at math, I'm doing this wrong. You got to get out of that mode because it'll take you down. To succeed, you've got to stay positive. Okay? Okay. I want you to join me at the middle board here. The next two boxes I would make smaller. Okay? So again, this is kind of a new concept of all the boxes don't necessarily have to be equal in size. I would split this in half. I would make this for section 2.4, and I would make this for section 2.5. We learned how to solve formulas, and we're going to do a problem like that here in just a minute. And we learned what we called is of what percent problems in 2.5. I would have at least one example in here, maybe two. I would have 2 to 3 examples in this one, okay? We defined that is means equals, of means multiply, and what means, the variable. We have no notes for formulas. It's the 3-step process to solving. We basically just did examples. These boxes definitely can be smaller. So problem number 9 on the test, we're going to come over here. Problem number 9 on the test is a solving formula problem straight from section 2.4. So I'm going to put a problem on the board right now, and it's going to kind of stretch you. And I want you to work on this. I'm going to give you 1.5 minutes to do this. Y equals 1/8 W plus 1/2 X plus 1/4 Z. We got that all on the camera? Okay, good. And I want you to think about this. First of all, everybody look up here. How many variables are in this equation?
3.
4. 1, 2, 3, 4. Y, W, X, and Z. 4 different variables. We cannot solve this equation, and get a numerical value because we have too many variables, okay? So what we do here is we say, hey, let's solve this for X, okay? So I want you right now, I want you to go ahead and solve this variable for X. Get X alone. Okay, go. 3-step process to solving. Do what you can here. Brother O, it's good that you're here today because Brother O was one of the engineers of our exams. That's great. You always wanted to be an engineer, didn't you?
Yeah, I remember you brought this up and I'm looking at it.
You're glad I brought this up?
Well,
I don't have my glasses on.
I don't remember this, but so this question is number 9. And so there's actually See that?
Which are average.
And then 4, like the one you just put in. It's in there because they're not exactly the same.
They're not. That's okay. So.
Similar concept though, I guess.
Yeah, for sure. But handled a little bit differently, for sure. You know, Brother O brought up something kind of cool with me here. We definitely did this problem on the homework, okay? And we were told to solve for one of these variables. I would go back, I put that example in. We're not going to do that one, but you could see something like that. One of the things we want to share with you, you know, no two snowflakes are identical, right? They say this, right? And so Brother O'Shaughnessy has engineered our testing program at campus, and you know, no two tests are identical either. The kind of matrix that we put together with all these questions coming together, you'll never take the same test twice because there's just different ways of doing the same problem. But one thing what you understand is every number is the same concept. So numbers 1 through 8 will all be 2, 1, 2, 2, 2, 3. Number 9 will always be a formula problem from 2, 4, okay? But it mixes them up with different combinations, okay? Okay, you got this one done? Let's quickly go over this. So again, a little different today. Not a whole lot here. I'm going to erase this real quick. Give us a little bit of space here. Okay. 3-step process of solving. Do we have fractions? Quickly, everybody. Yes or no?
Yes.
Okay, so what's the LCD?
8.
It's 8. Yeah, for sure. LCD equals 8. So we got to multiply 8 times this, and 8 times this, and 8 times this, and 8 times this. Balance rule. What we do to one side, we do to the other. We're going to get 8y equals, these 8's cancel, which makes what? You tell me.
1.
What?
1.
1w, which is?
W.
W, plus, what's this? 8 over 2 makes 4. What? 4x. And 8 over 4 makes 2, and we'll get 2z. Now your goal is to get x alone. Your goal is to get x alone. And so we're going to subtract w and subtract 2z. And what we do to one side, we got to do to the other. So we're going to get 8y minus w minus 2z equals, these cancel, 4x. Now who's sharing sides with x? 4. And we got to do what with it? Divide. So we're going to divide this side by 4 and this entire side by 4. Now here's my question for you, Brother O. Do we simplify this or leave it like this?
Sorry.
Do we leave it all over 4 or is the test actually bring 4 underneath each one?
That's a good question. Sorry, I was just there and then flipped off the page.
To me, this would suffice.
Yeah.
And the multiple choices on the test, stick with this.
I'm looking. Hold on. Keep going.
Okay. This is normally what we do here. Okay. Okay, so putting that example, let's go to the middle board. Putting that example in your visual chart would be really critical. Okay? All right, we're going to do 3 more. Numbers 10, 11, and 12. You can come here to the far right board. So numbers 10, 11, and 12 are what we call is of what percent problems. And if you remember, is, as we said, means equals, and of means to multiply, and what means the variable x. Okay? We're not going to do spend a whole lot of time on this. I'm just going to throw a few problems up here. If I asked you what number is 12% of 80, or if I did 15 is 29% of what number? Or if I told you that 80 is, we'll say 75% of, oh no, we'll do this, is what percent of 105? Okay. Drop down, translate. Do you remember these? Were these hard or easy? You tell me.
Depends.
Depends?
Depends on how confusing
That's
the
what old
question
people wear.
is.
Depends. These are
Depend them.
pretty straightforward problems. Let's do this
Some of the
real quick.
questions I
Okay?
had
In a different
text
color
was so
pen.
confusing.
I'm messing with you, Everton.
Some of the questions in one of the homeworks were like super confusing.
What's what number mean? X. What's his mean?
Equals
Equals. We always convert percent to a
decimal.
decimal. 0.12 of means
8.
multiply times 80. We multiply those two numbers. Do we have X on the calculator?
But
Straightforward. Okay, these three problems, I want these three to be easy ones for you. I want this to be kind of catch your breath problems. You know when you're running? Okay? Who's ever run before in here? Everybody's run at one time or another. I don't care if you just ran in recess or across the street, okay?
ran to the fridge.
You know? But there's certain points in time where the running feels kind of easy. Other times where you're like, whoa, this is getting harder. There's a point of what we call hitting the wall. There's second wind, okay? I want these three problems to be, you know, kind of a little more breezy, a little more jogging, like, oh, this isn't too bad, okay? 15, drop it down. Is means, quickly. Equals 29%. 0.29 of means multiply. What number is? X, okay? What do we do here? Divide both sides by 0.29. So 15 divided by 0.29 will give you your answer, okay? Let you finish that at home. 80. Is means equals. What percent is X of multiply 105? What do we do here?
Divide 105.
Divide each side by 105. Exactly. Now, here's the kicker on this problem. You're going to get a decimal. Will that be your final answer? No, you've got to convert it back to a percent because they asked for that. They asked for a percent. So this one, you got to change the answer to a percent in the end. Okay? Okay. Take pictures of anything you want up here right now. I'm going to erase the far left board. I'm going to give you just a second. I'm going to let Kenny do his thing where he pans onto one screen at a time. And then I'll meet you at the far left board. Actually, you know what? I'm going to meet you in the middle board. Let's go middle. So before Brother O'Shaughnessy and I got religion, we used to be drinking partners in college. I'm kidding.
Good stuff.
We never knew each other before the pre-existence. Stephen, he's laughing. Come on, where you at? You with me here?
Come on.
Yeah, Sister Pope, Alyssa, you rocking? You rolling? You got some kind of cool necklace. Is that a cat?
Yeah.
That's cool. That's cool. Okay. So, Jacob, you're really holding that mask in tight.
I'm tired. I'm holding myself up.
You're holding yourself up by your mask? I'm impressed. Okay. You guys ready? Okay. Section 2.6. You ready for this? I would make this box freaking beastie. Okay? I'd make this box beastie. This is section 2.6. This is word problems. And you're going to have 1, 2, 3, 4, 5, 6 boxes in there. You think back to what we did. We drew rectangular boxes. We had in the upper right hand corner, we had identifier, and I gave you something to memorize for each word problem type. Each of these boxes is a word problem type. You had percent, you had geometry, you had consecutive integer, you had the two-part problem, you had simple arithmetic, and over here you had the average word problem. And then you need to have an example of each one of these. Do we normally write a word problem, the entire word problem on our paper before we perform it, yes or no? No, of course not. It'd be a waste of time. But on a visual chart, do you need to write the actual word problem? Of course you do. If it's going to be a cheat sheet, okay, if it's going to be an actual cheat sheet, you'd have to have the problem to know what fetch you were doing. So you're going to write down one of each of these problems and then do the word problem, okay? This is going to be a huge box. Let's jump our attention over to the far left board. So in numbers 13, 14, and 15, we are addressing word problems from section 2.6. Okay? Numbers 13, 14, and 15. We're doing 2.6 word problems. And you're going to have one problem that's going to be a consecutive integer problem. You're going to have one that's going to be geometry and one that's going to be percent. We're going to do an example of each type. And this is where we're going to emphasize a lot of our time is on the word problems that are on the test. There are a total of 5 word problems on the test. 3 from 2.6 and 2 from 2.8. So 3 regular word problems and 2 inequality word problems, okay? So a consecutive integer problem, all right? I want you to think about the consecutive integers. Do you remember the thing that we had to memorize was the variables. And so in a consecutive integer problem, we know the variables. There's a first, there's a second, there's a third if we're given 3 consecutive. Okay? It doesn't always have to be 3. It could be 4 consecutive. It could be 2 consecutive. Okay? But typically we did like 3 consecutive. What's the first variable represented by? Always. What is it?
X.
Because?
Always.
What? Say it 1, 2, 3.
Always start with X.
We always start with X. That's right. What's our second variable going to be?
X plus 1.
X plus 1. And our next one?
X plus 2.
Okay. But sometimes it's X, X plus 2, and X plus 4. When is it that?
Odd.
That's right. Good job. If we have odd or even. So this right here is if we just have 3 consecutive. But this right here is if we have 3 odd or even consecutive. Okay? So I'm going to circle this in red. And I'm going to give you a big old warning sign. Because we talked about red means warning, warning, warning. We talked about black widows. Right? We talked about stop signs. I mean, this is your warning sign. On the test, when you do this problem, you have to look for that word odd or even. If it's not there, is it the top or the bottom? Top. If it is there, it's the bottom. Okay, very good. So we're going to do this. We have the sum of 3 consecutive even integers is 66. Find the numbers. Okay, at home or here, do this problem. Go. Okay? See what you can come up with. Yeah, Alexandra, give it a shot here. That couch is like holding you up, girl. You gotta feel picked on, don't you? I'm always talking about you and that couch. You and that couch have a very special relationship.
This is a different couch.
That's true. I did notice that. That is a different couch. You got all kinds of couches. You are the couch lover.
I am.
I'm going to call you the couch queen. La la la. Very good. I have a great couch at my house. I like to. Okay, let's do this problem. Can I erase this far right board about percent is of what? I give everybody time to get this picture. Cool. Joel's giving me the thumbs up. Joel represents everybody. I like it. Okay. Joel, since we're picking on you, let's continue to do this. What do you want to do for work in your life? What? No idea. Okay. Would you like to make money?
Yes, sir.
Okay, cool. All right. Joel. Okay, let's draw our attention back to the far left board here. Okay, so here's the deal. We have the sum. Sum means to add, right? And so we have to come up with our own plan on this. And that means that we're going to have the first plus the second plus the third will equal the sum. What is the sum?
66.
It is 66. That's right. What's our first integer?
X.
It's x. What's our second?
X plus 1.
Oh, it's x plus 2. Okay, and our third? X plus 4. And how do we know it was these bottom three instead of the top three? What was the key word there?
Even.
Even. Okay, even. Okay, if you miss that, okay, I'm just telling you, I need you to get this. Will every problem on the test be even? Yes or no?
No.
No, I told you there's a matrix. It mixes it up. Some will be even. Some will be odd. Odd and even are the same setup. And some will be neither odd nor even. It'll just be straight integers, and then it will be these three. So you've got to have your antennae up for this. You got to have your radar going. You got to be, ready for this, okay? So we take these three. Here we have x and x and x. Those combine to make 3x. 2 and 4 make what? 6 equals 66. We subtract 6. We subtract 6. We get 3x equals 60. We divide by 3. Divide by 3. And yes, I'm going fast because you were doing this on your own. So it asked for the numbers. So the first one is 20. So what are the three numbers?
20, 22, 24.
20, 22, 24. Say, woo, if you got it right. 1, 2, 3.
Woo!
Fantastic. That's awesome. I mean, if you did that right, you can feel pretty confident, hey, I can do this on the test. Okay, good work, good work. Okay, let's go to the far right board. Let's go to the far right board. We also have a percent word problem on the test. Okay, so our percent word problem, let's do this right here. So Joel received a 15% raise at work. He now earns $225,575 annual salary. That's good money. Who likes that? Okay, so Joel, I took care of you, man. You don't even know what the fetch you want to do, and I've already got you dialed in here. Okay? and so it says, what did Joel make before the raise? Okay, do this problem. I'm going to give you 2 minutes. Go. You know what to do. You've done these before. We've talked about them. Give it a shot. What did I call you one day? I called you the wrong one. Bonnie. Bonnie. That's right. Yo, O'Shaughnessy, man.
What's up?
Check out this bag, bro. Look at this.
Whoa, Mandalorian bag?
Yeah. You like Mandalorian?
Doesn't a new one come out this week?
I think it does come out like
Friday?
Oh, does the new Mandalorian come out this week?
30th. Let's go.
Who's a Mandalorian fan in here? Yeah, Baby Yoda. Dude, Stefan, he has a Baby Yoda.
I got 7 of them.
Yeah, you do.
Our last one, so bald. This
So
little
bald.
kid, I mean, he really does look like a Yoda.
I
All of our
remember the
kids were
day-
hairy except our last
I
one.
remember the day that number 6, you found out you were going to have number 6, and you were mad because you couldn't fit them all in the car you just bought.
Yeah.
Or something. Okay, let's look up here. All right? I want you to see something. We talked about percent problems, so here's the emphasis here. You're going to have a problem on the test, and it is going to be a work backward percent problem. And so we talked about you had to have something memorized. Original amount plus or minus a change to that amount would equal a brand new total. Okay? So we're talking about, instead of an amount, we're talking about original salary. What is the original salary? It's X. It's the thing we do not know. It is X. Good job. That's right. And are we adding or subtracting to that original salary?
Adding.
Adding. It's called a raise, fetchers. Yeah. He's getting more money. Okay? So we're adding. Okay? And we have a percent here, right? 15%, which is
0.15.
0.15. And then is that all we leave there?
No.
No, what do we put here? We always take a percent of the original amount, so it would be 0.15x. Okay? Now let's think about this. We have gone through this. We went through it with great fervor. Is Joel making 100% of his original salary? Yes or no?
No.
What is he making?
115.
And 115% converted to a decimal is 1.15x equals his new total, his amount he's making. We know what his new total is. We're working backward to find out the original salary. His new total is 25,575. Okay, so we got to divide both sides by
1.15.
1.15. What do you get?
100.
Find the length of a rectangular lot whose perimeter equals 60 meters if the length is 10 meters more than the width. Does that look right?
Yeah.
I think so. Okay? All right, folks. I don't want to spend too much more time on these, so I'm going to do this one with you. We don't have time. I'd love to give you a few minutes to do this on your own. So let's draw all our attention up here, okay? Let's think about this. We have the perimeter of a rectangle. So we know that equals 2L plus 2W. There's our formula. There's our plan. That's the hardest part of the problem. We've got that taken care of. What is the perimeter according to this problem? Quickly.
60 meters.
It is 60, okay? And we are looking to find the length. We have a comparison statement, and this is really important here. You're going to have a comparison statement or two on this test in the geometry problems. They love to use these. I told you this in geometry problems. And so you write it out. The length is 10 meters more than the width. And you write it all across in one line, and then you drop down, translate. Length is L. Is means equals 10 meters more than 10 plus the width, W. L equals 10 plus W. Where there's an L, you put in a 10 plus W. So here we have 2 times 10 plus W plus 2W. Make sense? Okay, so this right here is going to go right inside of that L there. So now we have 60 equals 2 times 10 is 20. 2 times W plus 2W plus another 2W. 60 equals 20 plus 4W. We're going to subtract 20 from each side. We get 40 equals 4W. We divide by 4, we divide by 4. We get 10 equals W. Now please pay attention to this. Everybody pay attention to this. You know, and I know, that on a multiple choice test, they're going to have 10 as an answer. Is this the right answer? Yes or no? Why isn't it the right answer?
Because it's
Because
not
they're
in
asking for the
meters.
length.
Because they asked for the length, and we've got the width. And so what is the length? 10 plus 10, which makes 20. And so length equals 20 meters is the answer to that problem, okay? Please understand how important it is to reread this, okay? Take a picture of this. We're going to move on, okay? I'll meet you in the middle board here. So our last two sections, as you're taking your pictures, our last two sections in our visual chart should be 2.7 and 2.8. And in this section, we need to discuss the flip principle, okay? And we have all of our notes on that from last time. Put that in there, and then you need to have at least 1 to 2 examples of solving an inequality where you got to flip the inequality sign, okay? And then in section 2.8, we talked about inequality word problems. And you know you have 2 of these, so there's an example of an average problem, and there's an example of a geometry problem. That's what we're going to do for the majority of our last 10 minutes of class today. But before we get into that, I want to talk to you about some of the other problems on the test. So We've gone through numbers, let's see, I have my little sheet here. No sheet. I do have sheet. Good. Brother O'Shaughnessy's laughing. I can't see any smiles in here. He's got
Sorry, I'm
he's-
wearing the
he's got
shield.
The shield.
Yeah,
You guys
shield's
got-
up.
Yeah. You got the muzzles in here. Okay. Number 16 and 17 on the test. Look up here. Number 16 and 17 are Number 16 and 17 are straight from section 2.7. This is solving inequalities. Okay? But I'm going to tell you right now that you have to know the flip principle, and you're going to be forced to use the flip principle on at least one problem. Okay? And the reason you're going to be forced to do so is you're going to have something like, I don't know, let's say we have negative 2x is more than or equal to, we'll say 5/8, okay? Negative 2x is more than or equal to 5/8, okay? I want you to do this problem really fast. Go, hurry. You do not have too much extra time. See what you can do. Can I erase the geometry problem down here? You guys got a picture of it? Yep, okay. Just a second, do that one. Okay. Okay, pick it on you, Alyssa. Here, look over here. Who's sharing sides with x? Negative 2. What's it doing?
Multiply.
Do you remember the flip principle? The flip principle only applies in the multiplication principle. And it only applies when we multiply or divide both sides by a negative number. Well, look at, we're multiplying by a negative number. We're going to have to divide by the negative number. So we divide this side by negative 2. And look at this, we have to divide this side by negative 2. So I got to tell you, I truly believe this on this test. I love the way this test is structured. There are problems that tax you a little bit, and they usually have fractions in them. And then there are a number of problems where they kind of give you a little bit of ease. To be like, okay, this is easier, I can do this, you know, catch your breath kind of thing. This problem might catch you. Watch this. These cancel. You divided both sides by a negative number, so x is, you got to flip this sign, less than or equal to, and then you can put this in your calculator. You have an A, B over C button, and it'll do it all for you. But if you don't use the A, B over C button, you got to recognize 5/8, change division to multiplication, flip the second fraction to 1 over negative 2, and you're going to get, you know, negative 5/16. And so this would be negative 5/16. Say woo if you got it right. Woo! Sweet. Great job. Alyssa.
Couldn't you also times it by 8 on both sides and then divide by negative 2?
Yeah! You could have got rid of fractions right off the bat, multiplied everything by 8, and then divided and flipped. I love that.
That's what I did.
Getting rid of fractions. Good job. And then you don't even have to mess with the fractions. And then all that anxiety of fractions is gone. Brilliant move. Brilliant move. Alyssa said, can we just take this exact same problem, negative 2x more than or equal to 5/8, multiply this side by 8 and this side by 8, get negative 16x, cancel these out, more than or equal to 5, then divide by negative 16, then divide by negative 16. X is, you divided both sides by a negative, flip that sign, and you got negative 5/16. And your fractions took care of themselves. Rock and roll. Way to go. Love it. Okay. Far left board. Come on down here. we have 2 inequality word problems on the test from section 2.8. 2 of them, okay? So listen, on the far right board, okay, I know you guys, the camera guys are like going like, ah, they're going crazy, okay? But the people in class, far right board, just one more time. You have 2 problems from section 2.7 where you're going to be solving, using the 3-step process to solve an inequality. And you're going to have to use the flip principle on one of them. On the other, it'll be contingent on which side to bring the variable to, okay? This over here, far left board, you have 2 word problems. I'm not going to do this problem with you. We did it last class period. We took a specific example in class. You had 3 of these to practice in your homework, okay? Alyssa receives an 88 and 93 on her first 2 exams. What scores can she get on exam 3 to average at least a 90? I want you to put an example of that in your visual chart. I want you to go back and look at our notes from last time, okay? You guys can rock and roll on this. But the key here is, check it out, at least, okay? And so whatever the answer is, X can be more than or equal to whatever the answer is, okay? Because Alyssa can get the same answer. She can get more than that answer, but she can't get less than, okay? And then we have another problem, all right? And it's an interesting problem. We've got to spend a few minutes on this, okay? It's a geometry problem. And Kenny, you might have to help me again. One side of a rectangle, so our second problem is a geometry problem. And it says one side of a rectangle is 5 times the other, okay? The perimeter, okay, is not to exceed, oh, let's see here, what did I do last time?
120.
120, thank you, 120. Find the possible values of X, which we will call the shorter side, okay? Okay, again, if we had time, we had even 2 hours to spend together. I would let you guys just do problems and then I'd work on with you, but we don't. So we're gonna do this together, okay? I wanna show you a couple of things that are really important here. Not to exceed. Tell me something. Are you to exceed the speed limit when you're driving on the interstate?
Theoretically, no.
No. Okay. Can you go the speed limit?
Yes.
Yes.
So if the speed limit is 80 miles an hour, can you go 80?
Yes.
Can you go 81?
No.
No.
Can you go 79?
Yes.
Yes.
And Stefan's like, well, technically I could go 81, but I could get a ticket. Right? I got you. I see it.
He can go
I-
65.
Let me tell you, I won't tell you how fast I go.
He can go 65, but you'll go get.
I'm going to tell you right now something very naughty. I went to Coeur d'Alene this weekend. I drive through Montana. Montana used to not have a speed limit many years ago when you were probably in embryo, okay, or maybe in the pre-existence, okay, but they didn't. And I used to drive through there, and I would go up to 120 miles an hour, okay, because I'm going to tell you something right now. You go 120 miles an hour for 3 hours, you're shaving off a good 2 hours of your entire journey, okay? It's phenomenal, okay? It's fun, okay? But I went 100 this weekend, and it was 80 up there, because you go through Montana, like, I'm out of here, man.
There's
I
nothing there.
can't resist it. What's that?
There's nothing there.
It's a beautiful drive. I love it.
Yeah, it's flat.
Man, you can just roll. Okay, check it out. Check it out. Not to exceed. You can be the same, you can be less, but you cannot be more, okay? So, we have a rectangle, okay? And we know we're talking about perimeter. So we have P equals 2L plus 2W. We treat it like an equal sign. So what's the perimeter? Quickly.
120.
It's 120. So we have 120 equals, okay? And let's think about this for a minute. We already know X is the shorter side. And it says the other side is 5 times that. So we have X and 5X. So one of these is 5X, we'll say the length is. And one of them is just X, we'll say the width is. Are we cool? So in essence, we have 120 equals 10x plus 2x. So 120 equals 12x. We divide by 12, we divide by 12, and we get 10 equals x. Now, please pay attention to this, because I need you to understand this. Can our width equal x? Yes or no? Can our width equal 10? Yes or no? Not to exceed. Can it equal 10? Yes or no?
Yes.
Can it be more than?
No.
Can it be less than?
No.
Yes.
Yes.
X is less than or equal to 10. Now, I'm going to draw something up here. And I don't have a ton of room, so look up here. If this is 10, and this is 5 more, this is 50, right? And 50 and 10 make 60, and 60 and 60 make 120. And if we don't exceed 120, we're good to go.
What?
Okay? But let's look at this. What if I cut this down to, look at this, what if I cut this down to 1? 5 times more would be 5. Okay? Still makes sense. This is 5 times more. 1 plus 5 is 6. 6 plus 6 is 12. 12 is less than that. 12 is less than 120, so we're good to go, right? So our width can be anything 10 and under here. Check it out. What is 0 less than 10? Yes or no? Is 0 less than 10?
Yes.
Yes. So if this width can be anything less than or equal to 10, and I make that 0, do I have a rectangle anymore? Do I have a rectangle anymore?
No, you should line.
I have a line. I got a problem, people. Look up here. So there's going to be an answer that probably says this is correct, and that is not true. Because 0 less than x less than or equal to 10 is the accurate answer. When you start doing word problems in the real world, you have to understand everything isn't always a solution. In geometry, we cannot have 0 or negative values for our geometric dimensions, or they become non-existent. Okay, we cool? Take a picture of that, and I'm going to go to the far right board. I'm going to erase the middle board. I'm going to talk to you about. We go to erase it. Okay, I'll let you take a picture of the whole visual chart thing. I'll erase the far right board. Okay, we got to hurry because time's up, and I got to share a couple more things with you about this test really fast. Okay. Okay, numbers 20 through 25. First thing I want to show you, there's going to be a triangle. They might have like x plus 15 and 2x minus 20 and 3x plus 5. And they're going to tell you that they want you to find x. What do you do? We want to find x. What do you do? Can you add 3x plus 5 plus x plus 15 plus 2x minus 20 and set it equal to?
180.
Can you do that?
Yes.
Yeah.
3-step process to solve it. You got a problem like that, okay? Next thing. Please watch this. We have 2 problems with number lines,
Oh, great.
okay? 0, 1, 2, 3, 1, 2, 3. If you don't pay attention to this, it's going to come back to bite you. But you've got it here. You can take a picture of it. If I have, okay, an open dot, and I go forever and ever and ever that way. The question on the test, please pay attention to this, is all about this open dot. It's all about that open dot. Okay? Open dot means more than or less than. Do you agree?
Put.
Closed dot means more than equal to, less than equal to. Agreed?
Put.
So if I'm more than, I'm going to be open dot going this way. If I'm less than, I'm going to be open dot going that way. Okay? If I'm more than or equal to, I'm going to be this way. If I'm less than or equal to, I'm going that way. Okay? Paying attention? They're going to have 4 equations. And they're going to tell you to, you listen to this? This is the thing. It says, which of the following inequalities has the graphical answer? They're going to give you 4 inequalities, and you'd have to solve them all if you don't pay attention. Because if one of the inequalities has more than or equal to, will it work for this?
No.
Nope. Okay? You got to look at that and be aware. You guys okay?
Put.
It's the open dot, closed dot review thing. Next thing. I'm going to give you another one where we have like 0, 1, 2, 3, 4, 1, 2, 3, 4, and we're going to have like an open dot here We're going to go over here. We're going to have a closed dot here. We'll say this is 1 and 2, and negative 1, negative 2, negative 3. And so you're going to have negative 3 less than x more than less than or equal to 2. Okay. This is what this would represent, and they're going to ask you to write this for this in multiple choice. You just got to recognize, again, open dot and closed dot and where you fit in between those, okay? Not hard. Last 3 problems on the test. There are 3 problems. Look at this. There are 3 what we call retro problems.
Retro.
Now, Brother O'Shaughnessy is going to kick my trash because I'm going to tell you this little story right now. I have been known occasionally at the end of a semester to eliminate the comprehensive final exam if students average higher than an 80% on comprehensive questions throughout the rest of the semester. We are giving you 3 comprehensive questions on this test from chapter 1. And on chapter 3, we'll give you some comprehensive questions. And on chapter 4, we will. And if you average an 80 or higher, I won't make you take the comprehensive final. Okay? It's kind of a nice deal because basically you're taking the final as you go. Okay? Look up here. You have 3 problems on the test. And the thing I want you to understand is this. Do you remember when we don't have an equal sign, we have a simplified problem? And you either have all numbers or numbers and letters. In an all number problem, the tool we used was the order of operations. In a numbers and letters, we distributed parentheses and then we combined like terms. You have one of each of these in the retro problems. Review your visual chart from chapter 1 and be ready for that. And then you have a simple substitution problem. It's something like this. If I had 2x equaled 5 minus y plus 8, and I said, solve this when y equals negative 12. Could you plug in that for y and then solve it for x?
Yes.
Okay? It could be a formula like Fahrenheit and Celsius, and they give you the Celsius value so that you finish it off and figure out what Fahrenheit is, but you're just plugging the number in and solving for the remaining variable. Okay? That's it. Folks, you're awesome. Sorry I kept you a little bit late, but we did a very, very thorough review. I say this last thing to you as you head out. Remember what I said at the beginning of class. This is a challenging test, but what you got here today should make you very comfortable with, I know what's on the test. Now you need to go and what Adam read to us at the beginning of class, you need to go meet this information halfway. You can't just take this and be like, okay, I can go take the test now. Now you need to go put your work in. Make your visual chart. Do your practice exam. Okay, review all these concepts. Good luck. I'll see you Friday.
Thank you.
Okay. Woohoo!
Thank you.
Thank you.